Hi there everyone. Today I'll be showcasing to you how I do LeetCode problem, and I think it's a pretty good template to follow to do LeetCode problem. Anyway, the problem that we will be doing today is this problem. I haven't participated in LeetCode competition for a while, contest. But anyway, let's get started. Uh, So, find the first player to win K games in a row. So, a competition consists of n players numbered from 0 to n minus 1. You are given an integer array skills of size n and a positive integer k where skills I is the skill level of player I. All integers in skill are unique. All players are standing in a queue in order from player 0 to player n minus 1. The competition process is as follows. The first two players in the queue play a game, and the player with the higher level skill wins. After the game, the winner stays at the beginning of the queue, and the loser goes to the end of it. The winner of the competition is the first player who wins K games in a row. Return the initial index of the winning player. So in here, we already kind of like got a brute force approach, which is we just do a array empty array, and we just continue to continue to append it and insert it, append it and insert it again, but that would be take too long forever, and that's not a efficient approach. And let's see how big K can get. So, oh my gosh, K can get really huge. So we need to think of a really smart way to do this problem, a really smart way. Basically we need a queue. Yeah, we need a queue that we can pop from front and insert to the back. Let me think how should I implement it. But first of all let's do some test case first. What I mean by I forget the exactly term, but basically it's kind of like a double linked list where I can insert in the top, and I also can insert from the bottom. I can pop from the top, and I can also pop from the bottom. So let me think of a test case where I would say, you know what, 2, 3, 4, and 8, and then 2. And the player has to win. Actually, you know what, I'm going to change 5. The player has to win 4 games in a row. 4 games in a row. K equals to 4. And actually, 1, 2, 3, 4. Note that 8 is going to win it all. So, we return 8. So the answer is return. Oh, we have to return the index, or what do we have to return? Player 2. Yes, we have to return the index. See, player 0 and player 1 play a game. Since the skill level of player 0 is higher, great. So player 1 is win. Player 0 and player 2 play a game. Since the skill level of player 2 is higher than player 0. Okay, so great. So right now, player 0 won the game. And player 2 already won the game, so that's counted as 1 already. Player 2 and player 3 plays a game. And since the skill of player 2 is higher than that of player 3, player 2 wins. The resulting kill is 24103. Okay. This is definitely tricky. I have to count in the factors of like the current gameplay as well. Let's say K equals 4. So let's just make sure it wins 1 time, it wins 2 times, it won 3 times, but I lost at the 4th time. Yeah, so this is 0, 1, 2, 3, 4. So we return index 4. Let's see in here. Actually, I feel like if we do a kind of like a double I think it's called Q or DQ. So let's say we import I think in Python it's called DQ if I remember correctly. We use DQ in here. Let's say we create DQ instead of stack or double Q. we insert the first two elements, which is 4, 2 in there, and 4, 2, 4 wins. So we count the iteration of, because we need to remember one thing. It's like, let's say if the let's say if this guy lost, like this guy lost, he would never get back his spot. Because why? The player with highest level is gonna maintain there until he won K games in a row. So yeah, we don't need to worry about that. So we need to have two factors to keep track of the winning. So let's say we keep track of the number of games called win is, let's say, let's just call that n, and keep tracks of the number of games that the current player has won. And also we gotta keep track of our queue size as well. I think of on time solution. A on solution. Just like insert everything into the double queue, and then yeah. So basically, the solution that I think of right now is is on complexity, so I think it should be fine. Or is there a smarter way to do it? Is there a smarter way to do it? Yeah, I don't think we need to do it that we don't necessarily have to create a queue, because let's say if the current player can win that amount of time of games, then this should be fine. But let's say if we iterate at the end of the games, let's say K is like 100,000 and 5 is gonna be 5 is gonna be the winner. It's just gonna keep iterating back and forth, back and forth. So basically it's the highest value. Yeah. Because let's say if K is greater than the length, we just return the max value. So actually all we gotta do is let's just keep track of the current value. We only need to iterate one time. So let's say yeah, this guy won. Yeah, I don't even need to keep track of the numbers come after it. Yeah. Yeah. We don't need a queue. And reason why we don't need a queue to keep track of the losing player, because the losing player won't be able to get back their spot, since their score will always be lower than the current player. So by this deduction or induction, we know that we don't need a stack or queue. We only need two variables. Which is n is to keep track of the number of games that the current player win, and current player level. So let's just say current player level. Yeah, basically that's it. So let's do the Sudoku already. So let's say we say the current player, which is the first player. So we just initiate current player level as the first value of the array, and n is set to 0. We loop the for loop, And actually, we got even a faster case as well. I mean, but we don't need to actually do that. So let's say we loop the for loop. If we loop the for loop, let's just see how long is the for loop. The for loop is two of them, so great. We loop the for loop, start at index 1. If the current player win, update and with addition 1. Otherwise, set n as 1. And what else do we have to do? Set n as 1 and update current player level to the new with the new winner player level. And by the way, the runtime complexity in here is on, and space complexity is o1 because we only need to keep track of 2 variables. And we check k. If n is equal to k, we return. We have to return the index, so we gotta keep track of 3 variables. Return the index. Index. I mean, actually, we can make current player level as a tuple, that contains the index and level of the winning player. So right now, yeah, let's try to and otherwise we just return the return the index, since the player will always be winning and won't lose, as given that this player will have the highest score. And right now, let's try to implement it. So alright, so right now let's just implement it. So let's see, we have to implement, let's just say, instead of current player level, let's just say current player equals to which is the first element of the skill, so skill 0, and the index of course is 0, and then we've got n is 0 as well. And then we iterate the for loop, so for I in range 1 with length skills, and let's just say if current player, so it's current player, just copy and paste, current player 0 1, which is greater, yeah, it's unique, so we don't need to worry about is how to say, like, it's equivalent. We don't need to worry about such case, because remember, everything in here is unique. All the elements in here is unique. So we just say, n plus equal 1. However, if this is the other case, then we gotta update everything. So I just say current player equal, which is the current skill set right now, which is skills I, and update the new index and have to set it to 1. Of course, we have to check, after we update n, we have to check k. So let's just say if n equal k, we just return current player, the first element, which is the index. Otherwise, we just return the current player index. And that should do it. Yep. Yep. Perfect. And yeah, runtime is on, and space complexity is O1. And we can see, we beat a lot of people in here. And I will be posting my solution and my, my pseudocode and my notes as well, and my test case. So before I wrap this, before I end this video, so let me just break down how I solved the LeetCode problem. So first of all, I read the problem first, of course. Everyone have to read the problem, of course. Then after I read the problem, I write some test case just to know the problem better. Or sometimes let's say we do have the problem. Actually, this helps a lot. Helps a lot. Then after that, I brainstorm some ideas. I just write some idea down. After you write some down ideas, eventually you have some. Let's just say at the beginning you have a huge hypothesis. There's a lot of possibility that you think could solve this solution. But then after you start writing it down, you're gonna see like there are certain patterns, certain hypotheses that somewhere, and eventually you get to idea. And after you get to idea, write it down in a cleaner notes, and then you just set out what are the variables that you need, and then you just do pseudocode, and then I implement it. And you always want to do pseudocode before you implement it first, because you can see our implementation takes no more than like literally 2 or 3 minutes. And this should always be the case. You shouldn't like let's say you see the problem and rush to code immediately. No, no, no. That's a really, really bad practice. Maybe you can put it off for easy problem, or maybe to a certain extent for some medium problem. But let's say when you get to hard problem, there's no way you can just code it right away. So yeah, hopefully you guys find this video helpful.